just to review, there's three ways we solve quadratics. The main two, factoring, most popular because it's the easiest. When you go to AP Calc, that's pretty much the only way we solve quadratics because they all seem to be nice and easy and work out like that. Most quadratics, though, can't actually be factored, so quadratic formula is really the way to go because it's going to work for every quadratic no matter what. And then completing the square will always work, and it just takes extra work. So if you're already in vertex form, then it's not bad. It's probably the easiest if you're already in vertex form, which is that one form, x minus h squared plus k, that form. Then it's, you might as well just finish it out solving that way. But quadratic formula is actually derived from completing the square. They completed the square on the generic formula. But just to review, so completing the square is when you get vertex form. So if you have if you have something in vertex form, a simple one would be like x squared minus 9 equals 0. Then you're going to be able to add the 9 over. Notice there's no x term. You square root both sides. Remember this method? I'm sure you do. And this also works if it was like x minus 2 squared plus 5 equals 9, something like that. It'll also work on as well. You subtract the 5, square root both sides. Notice there's no x term going on here. That's when we run into some issues. Factoring is when you have like x minus 2, x plus 3, and this works with the zero product property. It's the only one that works with the zero product property, and it's quick and easy. Our solutions are 2 and negative 3 because that's what makes the quadratic 0. Remember, these are all just different forms of the same thing. So they're all the same. They're going to get you the same answer. They're still going to get you the same solutions to a quadratic, just in different forms. So some are easier than others. Factoring by far the easiest if it's possible. Then quadratic formula, you should already know. So that's when you have a quadratic. Let's just say x squared plus 1x minus 6 equals 0. Main thing, it has to equal 0, and then we run it through the whole quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, I have that memorized. So that has to equal 0. So does factoring, though. Both of those have to be equal to 0. The completing the square method, that doesn't have to equal 0. It could, be like a 9 there, subtract the 5 and continue it out. So let's take a look at these. Michaela and Grace were trying to solve the equation. So different methods. Like I said, there's multiple methods, really 3 methods to solve these. So Michaela said, I'll factor the left-hand side of the equation as 2x plus 10, 2x minus 10. And yeah, that's the correct factoring. That's the whole, difference of 2 squares that she used. And solve it using the zero product property. So remember, we can solve the factoring using the zero product property. I should probably make a note there. So we're using the zero product property. So that's good. Yeah, hers works. Let's check out what Grace says. I'll isolate the x squared by adding 100 and dividing both sides by 4. And that's fine because there's no x term in the middle. You can do this. If there was an x term in the middle, like let's just say 4x squared plus 7x minus 100, that way is out. We can't use that. We then have to look into factoring or completing the square completely, all of that. But both of them work here. That makes sense. Let's look at this one. I can factor the left-hand side so that I'll solve using the zero product property. So what's wrong with this? If you factor the left-hand side as x plus 1, x plus 5, shouldn't it be equal to 0 in order to use the zero product property? So that is wrong. That's not going to work. Here they said I can solve it by completing the square. If I add 4 to each side, I can rewrite the equation as x plus 3 squared equals 12. Not sure why we're adding 4 to both sides though. Okay, that makes sense. So I'll show you what's going on there. So we have x squared plus 6x plus 5 equals 8, right? So the completing the square We just got done with that. So what multiplies to 6 and adds, or what adds to 6? Two numbers add to 6 are the same number, right? Because we're trying to get that perfect square. 3 plus 3 is 6. You just divide this number by 2. 3 times 3 is 9. So 9's that magic number. All they're doing here is instead of before, if you remember how I did x squared plus 6x, and then have you take that number, add 9, subtract 9, and then add 5, and then equals 8. I would have you do that. They're just saying, hey, let's just turn that 5 into a 9 straight up. And how can we do that? Well, we can just add 4 to it. But what you do to one side, if you do it to the other, the equation will still stay true. So that's what's going on there. So now this is x squared plus 6x plus 9. Great, we got our perfect square because now this is a 9 there. And we made sure to keep the equation true by adding that 4 to both sides. And now that perfect square, we can see this is the factoring, right? Both factors are 3. And so that actually makes sense. So we're going to go with the second one. Todd is good. Let's look at this one. This is some also that don't quite work out. Lucas said the x squared term is isolated, so I'll take the square root both sides. The problem is, look at that x. So if you square root both sides, x is not by itself. There's another x inside the square root. It just throws things way off. So Lucas is wrong. That only works if this wasn't there. So Lucas is out. Let's look at what Tony said. I'll solve using quadratic formula with a equal to 1, 16 for B, and 25 for C. Well, let's think. Doesn't the quadratic formula, remember we have to make sure that function equals 0? So we need to move over that 16 and also that 25. So minus 16x minus 25 to the other side as well. And you would have x squared minus 16x minus 25 equals 0. So actually B would be negative 16 and C would be negative 25. So in this case, both of them are wrong.